Yet again, jumping the gun. So this is the inverse Laplace of, this is example 6. I might start incorporating examples after this of solving what they call initial value problems, aka differential equations. And I won't go from first order to second order. I'll be doing a bunch of second order, seeing as those are where most of your questions will be. And yeah, maybe a third order. I've never actually done one, so I might have to study that myself. So let's do it. So we're doing the inverse Laplace of s minus 21 over 4 all over s, 7s squared plus 11s plus 1. So I'm going to split the fraction, the first thing. So this can be rewritten as the inverse Laplace transform of s over 7s squared plus 11s plus 1. Close it, and then that's minus 21 over 4 multiplied by the inverse Laplace transform of 1 over 7s squared plus 11s plus 1. Cool. So let's continue. So I am going to complete the square because I can't actually factor this properly, as you can probably imagine, right? So 11 divided by 2 squared is equal to, well, 11, 121 over 4. But this is going to, before I do that, sorry, I have to take the 7 out the front, right? So, 7 s squared plus 11 over 7 plus 1 over 7. 11s over 7, sorry. Alright, cool. And now I can rewrite that as the inverse Laplace transform of s over 7, and then that's s squared plus 11 over 7s plus 1 over 7 minus 21 over 4 multiplied by the inverse Laplace transform, still of 1 over 7, s squared plus 11 over 7s plus 1 over 7. I know it's getting wonky, but let's continue. So what we're going to do here is going to take 1/7 out the front. So that's 1 over 7 multiplied by the inverse Laplace transform. That's like my favorite thing to say, multiplied by the inverse Laplace transform. Say it so elegantly. Alright, I need to get a last. So that's multiplied by s, yeah, you know the drill. Now I can complete the square. So let's just do it off to the side here. So s squared plus 11 over 7s plus 1 over 7. I can take the middle term, 11 over 7, divide it by 2, square it, but a over b over c is equal to a over bc, so 11 over 7 times 2, that's 14. That's 11 over 14 squared. And I don't know what 14 squared is. Sorry, I know it's kind of embarrassing. So I think it's like 191 or something. I don't know. 11. Hold on, let's do 14 squared. 196. Man, I was close, but whatever. Alright. So this is equal to 121 over 196. So what I have to do right now is say this is s plus 11 over 14 squared, then that's minus 121 over 196, and then plus 1/7. And then that's minus 21 over 4, you know the drill. You know what, I said I was going to fix the wonkiness, but I continued to do it again. That's 1 over... and that's 7's out the front now, so 7 times 4, that's 28. So 21 over 28. And then that's going to be s plus 11 over 14 squared minus 121 over 196 plus 1/7. And obvious, this is just completing the square, right? So I minus 121 over 196 because I just added it. So that's the reasoning behind that. So let's rewrite it. Let's put a line and let's get some order here. So 1 over 7. Now, I'm going to get my trusty calculator out real quick and do minus 121 over 196 plus 1/7. That's minus 93 over 196. So, let's rewrite it. This is actually a really long example. I didn't even realize. And then that's minus 93 over 196. And then that's minus 21 over 28 inverse Laplace transform of 1 over, oh, this is getting a bit awkward, isn't it? S plus 11 over 14 squared minus 93 over 196. Cool. Alright. Now, what can I do here? I have to realize that this is the fs minus a little trick. This is a shift, right? You know what? I'm going to do a part 2 to this video because this is going to be a very long video if I continue to do it. So yeah, stay tuned for part 2. See ya!